Hey guys, welcome back to my YouTube channel. I hope you all are doing well and you all have liked the previous video. So, before starting today's video, let me introduce myself. I'm Karthik Agrawal, currently studying in Sri Venkateshwara College of Engineering. So, let's dive in today's topic. Today we're here to learn about Python programming language. Before starting, let me give a small introduction on Python programming language. Python is a popular programming language. It was created by Guido van Rossum and released in 1991. Python has many uses. Python is used for web development, software development, system scripting, artificial intelligence. It is also used in making applications and gaming applications. Now, let's see the definition of Python programming language. Python is a high level general purpose programming language. Its design philosophy emphasizes code readability with the use of significant indentation. Python is dynamically typed and garbage collected. It supports multiple programming paradigms, including structured programming language, object oriented programming language, and functional programming language. Now, let's move on to the next topic, that is data types in Python. So, let's see what are those. A data type is an attribute associated with a piece of data that tells a computer system how to interpret its value. Now, let's check different data types in Python. There are different data types in Python such as numeric data type, boolean data type, sequential data type, mapping data types, and set data type. Let's see each of them. Numeric data types. These are used to store numbers. They include integers, floating values, and complex numbers. Now let's move on to the next type of data, that is sequential type of data. In Python, we have a special feature which helps us to store multiple data in a sequence, and there are of three types: list, tuple or tuple, and string. Let's see each of them. List is a ordered pair of collection of data which are mutable. That means we can change the list. Lists are created with the help of square brackets. Now let's see what are tuples. Tuples are also ordered collection of data which are immutable. That means that once a value is entered in a tuple, those values are fixed. Tuples are created with the help of parentheses or normal brackets. Let's see the third type of sequential data type, that is strings. String is a collection of characters, and we can create a string data type with the help of single or double quotes in Python. Now let's check the next type of data type, that is Boolean data type. With the help of Boolean data type, we can represent whether a value is true or false. Now, next data type, that is dictionary. Dictionary is a mapping type of data in Python. Dictionaries are used for collecting data, and its collection is done with the help of key value pairs. A point to be remembered that in dictionaries, every key should be unique. That is, no two keys should be similar in Python. Key and value are created with the help of colon in Python, and dictionaries are usually created with the help of flower brackets. Now let's check the last data type, that is sets. Sets are an unordered collection of unique data in Python, and we are creating sets with the help of curly braces. There are one more type of set, that is frozen set. This is same as normal sets, but the only difference is in frozen sets we cannot change the value. That means they are immutable version of sets. I hope you all have understood a bit of Python data types. Now let's check a following code, and you all can see I've created a code where I'm displaying different types of data types. Like variable A represents numeric data type, which is class of integer. Numeric B represents floating value. Similarly, we can see that there's a string which says my first Python video, and there's a list which I've created with the help of square brackets, and a dictionary which I've created with the help of curly braces. And similarly, you can see a tuple which I have created with the help of normal brackets and a set and a frozen set. And to display whether it's a integer, float, or a list, I've used a built-in function that is type of. These are the standard or built-in data types in Python. There are also other data types that can be imported from modules such as date and time types of data using the module date time. So I hope you all have got some idea of data types in Python. Now let's move on to the next topic and understand what are functions. In Python, a function is a block of reusable code that performs a specific task. Functions provide modularity to your code by allowing you to break it into smaller and more manageable pieces. Here we can define and use functions in Python. In Python, there are generally four types of functions, that is built-in function, recursion function, lambda function, and user-defined function. But I would like you to specify only built-in and user-defined functions because they are the most important part in Python, and if you all can understand these two functions, it would be helpful. So let's move in. Built-in functions are the functions that are already defined in Python language. We can without defining them. Some examples of built-in functions are print, length, range, etc. We can also access built-in functions by the use of import statements. The import statements allows us to import a particular module into your following code. Now let's understand what are modules. Modules are a collection of code that can be used to perform some common task. Instead of writing the 4 to 5 lines of the code, we can import the following function by calling the module using import keyword. Now as you all can observe in the image, I have given some built-in functions in Python such as abs, max, ASCII or byte, etc. And I have earlier discussed there's a one built-in function which I've used, that is type of. Now let's move and see some codes. Since you can see, I have written a code displaying different built-in functions in Python. As you can see in the first line, I have written from NumPy import star. Here, NumPy is a module which is used to perform mathematical operations such as square roots or finding squares or cubes, etc. And star here indicates means it calls all the functions from the NumPy module. Now as you can see, I've created four variables a, b, c, d, and I've performed some following tasks. And as you all can see, I've used to perform the square root of a particular number. I've used to perform squares of a particular number. We can write we can also find the squares of a particular number by writing variable name is equal to the number which we want and give 2 times the symbol of into with the following number as 2, 3 or 4. When for example, we can give d is equal to 2 into 2, which gives 2 square, or we can give 2 into 3, which is 2 cube. Similarly, we can write numpy function as import numpy as np. Here np acts as a variable, and whenever we have to perform some numpy operation, that time we have to write np dot and write the function name such as np dot sqrt of. I hope you all are understanding, and from the following code you can see what I have given and the following output. I hope you all got some basic idea of built-in functions. Now let's understand user-defined functions. In spite of having s- great built-in functions in Python, still for better performance and user experience, Python allow us to create our own functions. We can create our own functions using the keyword def. As you all can see in the following diagram, there we have given the ways how we can create a function. That is, first we have to give a specific keyword, that is def. Next to def, we should give a white space and then write the appropriate function name. Then followed by brackets, we have to give parameters. And then colon acts as a terminator, and colon is important while defining a function. As you can see in the next line, there is some space. This space is called indentation. Minimum four spaces is required. Then we can give the statements or the following codes or expression what you want to do in the following function. To execute a function, we simply writes its name followed by parentheses, optionally passing arguments if the function required them. Functions can accept 0 or more parameters as you specify default values for parameters, making them optional. Let me discuss how we can call a function. There are usually two calling methods such as call by value and call by reference. Now let's see each of them. Now let's understand what is call by value. Call by value means that when you pass an argument to a function, a copy of the argument's value is passed to the function. This means that any changes made to the argument inside the function will not affect the original argument. Whereas call by reference means that when you pass an argument to a function, a reference of that argument itself is passed to a function. This means that any changes made inside the function will not affect the original arguments. Since Python does not supports call by reference in a traditional sense, however, it does support a mechanism called pass by object reference. This means that when you pass an object to a function, a reference of the object is passed to the function. If the object is mutable, then any changes made to the object inside the function will affect the original object outside the function. A bit tricky, but let me explain this by following code which I've written, which shows call by value and call by reference. Here, in call by value, I'm giving a immutable data types such as string or a numeric data types, whereas for call by reference we should give mutable data types such as a list or a dictionary. And as you can see, I've created a function add and swap of a and b respectively. Then you can see during function of add, I have called add function, and you can see before and after and during the function changes. Similarly, you can see the changes in swap function before and after. But as you are seeing, just observe in call by value and call by reference. Since I've given an immutable data type in call by value, the value changes inside the function and it does not affect the original value, whereas in call by reference I've given a mutable data type such as a list, and when the value changes inside the function it automatically changes the value outside the function. I hope you all have understood call by value and call by reference. Now let's move on to the next topic, that is exception handling. Exception handling is a mechanism that allows you to gracefully handle errors and unexpected situations in your code. In Python, exceptions are raised when an error occurs during program execution, and they can be caught and handled using try, except, finally. Try, except, and finally are the keywords. And to do this, we have to give this keywords with a colon. Now, in try block, we actually type the code which has to be run. In except block, we write that if the if the code catches an error, then what should the compiler do? And in finally block, we give the concluding statements. Now let's understand some exceptions in Python. Wa- Let me discuss some common exceptions in Python, that is zero division error. It is raised when any division by zero is encountered, or another common error, that is value error. Value errors are raised when a parameter has an invalid value such as square root of minus 10, or type error. Type errors are raised when function parameters is given in wrong type. Let's There are many common example errors such as index error, name error, import error, etc. As you all can see the following table, I have discussed each type of errors and I've defined them. I hope you are understanding exceptions. Now, for better understanding, I've given few examples of exception handling. In first one, I was trying to do division. I've written in 5 block, enter two variables as numerator and denominator, and I've performed the following division expression, and I want to print it. Now, if the variable b, that is denominator, is equal to 0, then it shows an zero division error, and you can see the following output, that is I have given enter numerator, that is a, which is 12, and enter denominator, that is b, which is 0. Since 0 since b is equal to 0, it shows that error denominator is 0. The block is finally over. Necessary to give the finally block, but for better execution and looking of the program, it's better to give finally block. Similarly, you can see type error, where I wanted to add an integer with 1, but as you can see, I've given a in quotes 1. So if type of a is not equal to integer, it prints that there is an type error, which and shows that A has different data type. Since I earlier discussed that anything in single or double quotes is an string, and we can't add one with a string, so it's an error. Let's move on to a short program, that is guess a number. Now, to enter a code which main function is to guess a number, that that time we have to follow some steps. That is, in first step we have to create a variable, and that variable should generate a random number from the computer. Second, we have to create another variable, that is what is your guessed number. And the third step is, if you want the player to have multiple chances, then we have to create another variable for how many chances you want to give the player. Then, using a loop statement and if elif ladder, we have to check whether the random number is equal to guessed number or no. If the guessed number is equal to the random number, then we have to print hooray, congratulations, you have guessed the number correctly. Or else we have to print that your guess was too high or low. Now let's check the following code. So to generate a random number from a computer, we have to import a module, that is random, and from the random module we have to use the function, that is int. I hope you all have understood, and as you can see in the following screen, in the following code, I have created a variable n, which is equal to random dot randint, and I've given a range as 1 to and 100. This means that the computer generates a number between 1 to 100, but if you all want, you can give the range as 1 to 10 or 1 to 20. Similarly, I've created another variable, that is gs. I have created this variable for number of guesses. Since I have started with 0, you can write gs is equal to 1. It's up to you. Now, if you want the player to have multiple chances, so the best method is create a while loop. Now, so I've written while gs less than 10. A point to be remembered, since I've given gs as 0 and my while statement says that gs is less than 10, so then looping starts from 0, 1, 2, 3. But if you have given from 1 and if you still write gs is less than 10, that compiler gives only 9 chances to the player, which is kinda unfair. So if you have given gs is equal to 1, that time your while statement will be gs less than or equal to 10. I hope you have understood. Now let's create another variable to enter a guessed number. So I've created another variable, that is g underscore yes, and now we you have to use the if elif ladder to check that our guessed number is equal to random number or not. So first statement, if g underscore s is equal to n, it prints that hooray, congratulations, you have guessed the number correctly. And we use the break statement to jump the compiler out of the following loop. or else guess number is not equal to n. It prints that whe- whether your number is too high or low. Now, since we have already decided that we have to give the player some chances, so we have to keep increasing the number of guesses. It's because our initial number of guesses was 0, and we have used while gs is less than 10, so we have to keep increasing the value of gs. So I've used an increment statement, that is gs plus is equal to 1. This means that gs is equal to gs plus 1. We can end our code here, but for better looking we can write one more if statement and write that if gs is equal to 10, that is if a number of guesses is equal to 10, then we print the following statements, that is you ran out of guesses and the number was n. Now you all can check the output of this, and you can count and see there are totally 10 guesses I have got. And yeah, I lost it. I have guessed as 85, but the actual number was 86. Pretty much small difference, but yeah, I have lost. I hope you all have learned something in this video. Thank you very much. Don't forget to hit the subscribe button and like this video.